Hi. Yeah. A very good morning, everyone. Thank you for being here. And thanks to the seminar organizers for having me this opportunity to talk here and present my research with you all. And I'm Avinash Chaturvedi. Currently, I'm a postdoc at the Leibniz Institute for Astrophysics in Potsdam. And today, I'm going to talk about the mass assembly of Fornax galaxy cluster. My work is not directly related with the ESO wide field imaging surveys, but it is based on utilizing those surveys, and therefore the title, Utilizing ESO Wide Field Imaging Surveys to Learn about the Mass Assembly of Fornax Cluster. This work was done here during my PhD under supervision of Mikhail. Thanks to him for being a wonderful supervisor. And as I go along, I will tell you which surveys we used for this work. And let me start with the galaxy cluster, and this will also bring me to the motivation behind using Fornax cluster. So galaxy clusters are the most massive gravitationally bound objects in the universe. And here what you see is a beautiful image of the Fornax galaxy cluster. Studying the mass assembly of a galaxy cluster, we could learn various things in general. For example, on a large mass scale, in the center of a cluster environment, we have a massive galaxy. For example, here it's NGC 1399, and we could learn about its structure, formation, dark matter content. This is on a large mass scale. At the same time, in a cluster environment, we have low mass galaxies. Here is an example of NGC 1427A. And as these objects are infalling in the cluster environment, we could learn that how the cluster environment is impacting the growth and evolution of these objects. This was on a small mass scale. At the same time, if we extend our area in the physical scale, then we could learn that how the different galaxies are interacting with the halo of the central galaxy. Here, I'm showing a G-band image of the extended halo of NGC 1399 and the different neighboring galaxies. And these events leads to generate the accretion, merger, and intercluster light. Basically, in summary, galaxy clusters are important objects, and we could learn various things. And Fornax is quite spatial to explore these kind of points. Why? Because Fornax is one of the nearest and densest galaxy cluster, and it has been observed quite well in the different photometric wavelength region. And thanks to the ESO wide field imaging surveys, such as Fornax Deep Survey uh, of the Fornax cluster performed with the VST, with the VIRCAM and the photometric band UGRI, or the VISTA VIRCAM in the K band. And these surveys have helped in exploring the Fornax cluster environment in quite detail. And what I'm showing here is just the layout of the Fornax deep survey over the full Fornax cluster. This is roughly around 26 square degree. And this blue rectangle shows the image of the Fornax cluster, which I was showing before. And these surveys has been really important in highlighting the active mass assembly nature of the Fornax in the region. This is again here the G-band image of the extended halo of NGC 1399, and this shows that the halo of this galaxy, central galaxy, is interacting, or the other galaxies are interacting with its halo. For example, NGC 1404 or 1387. More deeper, these studies have shown that there's a presence of stellar and tidal streams. This is again coming from the Fornax Deep Survey from Enrica study, from Irish et al. And they have detected a faint stellar bridge connecting the central and its neighboring galaxy. Moreover, the global clusters of Fornax cluster from these observations have shown that there is a wide distribution of global clusters in its environment. What you see there is the surface density map of global clusters in Fornax cluster environment. That blue rectangle is just to guide your eyes to the image I was showing. And here the blue color shows a higher density of global clusters, and the red one is decreasing. All these points makes Fornax an ideal target to learn about its mass assembly. And with mass assembly, what I meant is to get the total mass profile, which is the sum of the baryonic and dark matter halo, and also learned about its intracluster environment. And this motivated us to use basically these photometric surveys and go a step further in order to perform a spectroscopic survey using the ESO VLT. And this we call as Fornax cluster VLT spectroscopic survey. And in my case, we use global clusters as the kinematical traces to perform the mass modeling of central galaxy NGC 1399, and also learn a bit about the Fornax intracluster environment. Now, for the spectroscopy, from this Fornax cluster VLT spectroscopic survey, this comes from the WMOS multi-object spectrograph. And here in this plot, you see the red box, roughly the red box denotes the layout of the WMOS observations on this central 1 square degree of the Fornax cluster. And in comparison, in contrast to the previous observations, plans such as Subert et al. Or the green one, this was designed to have a uniform coverage of global clusters in its central region. And just to emphasize again that the global cluster selections for these spectroscopic survey were based on the Fornax deep survey, which came from the Cantiello et al. Using the color plots such as shown here. And now, going from this to the spectroscopic, one of the model spectra of global cluster from this observation. Here, what you see in the black is the global cluster spectrum with a signal to noise ratio of 25, and the red one is the model spectrum with the PPXF, which is a Python tool which uses spectral features to give you line of sight velocity or other moments. And right side, you see the zoom in feature for different absorption features such as H alpha, calcium triplet. And we use these zoom in absorption features to select the bona fide global clusters in the Fornax environment. And before I show you how many global clusters we detected, I would like to show you this plot, basically the radial velocity map of global cluster. This data set was previously analyzed in 2018. What you see here is that each dot is a global cluster, color-coded with its line of sight velocity. And the different green cross represents the major galaxies in the central 1 square degree of Fornax. The central one is NGC 1399. And after our analysis, we reanalyzed this data set. We basically doubled the global cluster numbers on the same data set. So this is the first point to take away, that reanalyzing the WMOS data set, we doubled the global cluster numbers on the same data set. And if I combine this global cluster catalog with all the previous velocity measurement, then this produces one of the most extensive global cluster radial velocity catalog in Fornax environment of more than total 2,300 global clusters. What you see here is the radial velocity map of global clusters, showing each dot overplotted on the photometric surface density map coming from the Fornax deep survey. The white color which you see is the higher density region of global cluster, whereas the gray one is the low or less region. And with our kinematical sample, we characterize these previously detected substructures like in between present here and all these ones. And global cluster comes in two categories. One, which is the metal rich or the red global clusters, and blue, which are the metal poor. And we were interested in knowing what kind of global clusters are present in these intracluster regions where there are no galaxies or substructures. And using the color plot, I divided the sample, and this is how does the phase space diagram in the color looks. So the visual impression from this, what you get is that in the outer regions, you see more blue dots. So basically in Fornax intracluster regions or the substructures, we find that these are dominated by the blue global clusters, which are the metal poor global clusters. And in the central region or the individual central regions of the galaxies, we find that the red global clusters are concentrated. So till now, I talked about mainly the global cluster kinematical characterization in Fornax central 1 square degree, but this is not yet the full picture because I told you that we are interested in mass modeling. So now the goal is to use this catalog, radial velocity catalog, to get the mass profile of the Fornax cluster, with the goal to have a total mass estimate, learn about the dark matter halo, and also learn about the effect of the intracluster global clusters on the mass modeling, and also a bit about the orbital distribution of these global clusters, whether blue or the red have different kind of orbital distribution or not. And for the mass modeling, I used Jean's modeling, assuming a spherical symmetry and non-rotating system. And just to show you what are the important things in the mass modeling, we have observables such as here the global clusters, and then to learn the effect of the intra-cluster global clusters. Why I'm showing you this? Because till now, the mass modeling of the central galaxy has been performed within this region, and we have an extensive sample of global clusters in these outer regions. So I was interested in knowing that what could be the effect of including intra-cluster global clusters in the mass modeling. For this, what I did, I divided the total sample in two subsamples, here marked in the red circle. This is these global clusters and the full sample. And I performed the mass modeling using these two subsamples to see how much is the mass profile different. And what we actually model, like from these global cluster radial velocity, you can get the velocity dispersion, and this we can model. And what you see here is this, the blue one is basically the velocity dispersion of blue global cluster, and this is the red one. So you see there is a difference in the velocity dispersion, and this is coming from the different phase space properties, kinematics, and maybe this has also a hint about the orbital distribution. And this we could learn from the mass modeling. And now coming directly to the results of the mass profile, and I want you to focus on this continuous line. For the mass modeling, I used NFW and the dark Bouquet halo. And here, these continuous lines shows the total enclosed mass profile as a function of the radii for this whole sample. And what we noticed that independent of the dark matter halo I used, the mass profile for this full sample shows a quite excellent agreement. Although the mass profile also from this inner sample, which is shown here by the dashed line, also agrees, but the effect of including the intra-cluster global clusters, we find that the mass profile agrees quite well independent of the dark matter halo. And for the orbital anisotropy, for the moment, accept is that if beta is a parameter, if it's positive, it means that there is a radial orbit, or the orbits are elliptical. And if blue global clusters, which we are seeing in the outer skirts, if these are accreted from the low mass systems, we should see them on the elliptical orbits. And this, we find that in the outer skirts, for the blue global clusters specifically, we find that there is a radial anisotropy, which means that these objects, these global clusters are accreted one. This is also coming, kind of giving a confirmation which we saw in the phase space. So I started from galaxy cluster, Fornax cluster, global clusters, and then mass modeling. But still there is so many things to learn, like what is the origin of the global clusters in the intracluster region, and what kind of preferred dark matter halo. So this motivated us to lead further the Fornax cluster VLT spectroscopic survey. And here, this black square basically denotes the WMOS observation, but we wrote the proposal, extended further the VLT spectroscopic survey with flames, here shown by these circles in the black font, and forced two observations. And the goal from these observations are to learn about the metallicity of global clusters and basically of intracluster global clusters, and also perform advanced dynamical modeling to know more about the specific effect of the intracluster global cluster. And this brings me to the conclusion that using the WMOS observations, we have produced one of the most extensive radial velocity catalog in Fornax cluster. The second point to take away is that we find that the metal poor, which are the blue global clusters, dominate the Fornax intracluster regions. And with our catalog, we provide the substructures identification and kinematical characterization. Using our radial velocity catalog, we provide a new mass estimate for the Fornax cluster. We find that including the intracluster global clusters produces a total mass profile which agrees quite well independent of the dark matter halo we use. And for the blue global clusters, we find that in outer skirts, they show radial anisotropy. This gives a hint that these are the accreted components in the cluster environment. Thank you.